Given tan A is equal to 4 by 3, find the other trigonometric ratios of angle A. Nothing is given to you except the value of the tangent of angle A is given to you. So let us find the other trigonometric ratios of this particular angle and see how we can do it. I have drawn the triangle over here and I have taken angle B to be 90 degree. It doesn't matter whether you take B or C as a 90 degree. The reason being we are bothered only about A for now. So tan of A is defined as the opposite side by adjacent side, which is BC by AB, and that value is given by 4 by 3. Now, one of the very common mistakes that students do is they take the value of BC as a 4 and the value of AB as a 3 and do the sum. Now, when you do the sum, you will get the correct answer. I will tell you why. But this part where you take the measurements individually as 4 and 3, you know it is wrong. I explained to you why, like by taking the mark of two students, which are in the ratio 5:2, and it is not right if you take the mark of one student as a 5 and the other student as a 2. It is the lowest form of the ratio after taking out all the common factors. Correct? So, how will you take the sides as? We will take the sides as 4k and 3k, or you can take it as 4x and 3x, whichever variable you want to use. So, this is 4x and AB, this is 3x. Now, if this is 4x and this is 3x, what can you say about the hypotenuse? It is 16x square plus 9x square, which is root of 25x square, giving us a 5x. So, this is 5x. Okay. Now, let us start with the trigonometric ratios of angle A. Sine A. Sine A is opposite side by hypotenuse, which is 4x by 5x, which gives us 4 by 5. Now, do you understand, even if you take the sides as a 4 and a 3, why you will get the correct answer? Because again, it is a ratio. When you take this as a 4 and this as a 3, this becomes a 5. So, my sine A will become 4 by 5. So, the final answer will be correct. But if you take a wrong concept, work on it and end up with the right answer, you will not get the correct, you will not get the mark. Okay, because the ratio is a totally different concept. You cannot take the absolute values. You have to multiply it with a common factor over here. So, do not take the sides as absolute values. Always multiply with a k or an x. Okay, so next one is cos A. Cos A is adjacent side by hypotenuse, which is 3x by 5x is equal to 3 by 5. Okay. Tan A is already given to you. Now I have to find cosec A, which is the reciprocal of sin A, which is 5 by 4. Sec A is a reciprocal of cos, which is 5 by 3. And cot A is a reciprocal of tan, which is 3 by 4. Okay, now this is one sum that you have to be very careful about. Do not take the sides as absolute values. Always put the common factor x or a k. But if it's an MCQ, you want to save time, easily you can put it as 4 and 3 because it's only calculation. But always understand, in the case of ratios, when you are doing a sum like this, please use the common factor. If angle B and angle Q are acute angles such that sine of B is equal to sine of Q, show that angle B is equal to angle Q. Now, we are given two angles and it is said that the sine of those angles are equal. We need to prove the equality of the angles. Now, you need to understand that angle B and angle Q belong to two different triangles. So, let us name the triangles as ABC and PQR and start with how to prove it. Here you can see that I have taken two triangles ABC and PQR and I have taken angle A to be 90 degree because I needed angle B to be free for to apply trigonometric ratio. So this is angle B and purposely here I have not taken this as angle Q, I have taken this as angle Q to make you understand that these are two different triangles and the angles also have no similarity right now. We need to prove that these angles are equal. Now, in two triangles, how will you prove angles are equal? Two triangles and angles are equal means either they have to be congruent or they have to be similar. These are the only two ways in which the angles of two triangles can be equal. So can we apply congruence over here? We have no idea about the sides. So let us start with taking the trigonometric ratios and see what all data or what all details we can find from this information. I have written sine B and I have written sine Q. Sine Q is opposite side by hypotenuse, which is PR by QR. Okay. So now in the sum, we need to show the equality of two angles. What is given to us? It is given to us that sine B is equal to sine Q, or basically when we are writing down the values of sine B and sine Q in this way, we are basically getting the ratio of the sides. How do we prove angles are equal of if two triangles are given to you and you have to show angles are equal and the ratio of the sides is given to you? How will you prove it? Immediately, the first thing that should strike you is that I need to prove that the triangles are similar to each other. Okay, see, chapters are linked. You cannot say trigonometry is something exclusive. Trigonometry is basically ratio. So if the ratios are given, to prove the similarity of the triangles, you should take the ratios of sides. You cannot prove congruence in this case because the sides may or may not be equal. You have no idea. So let us see whether we can prove similarity. Now you know that AC by BC is equal to PR by QR from this particular data. Let me cross multiply. If I write AC, not exactly cross multiply, but in this way. AC by PR is equal to BC by QR. Why did I do that? In this case, I am having the ratio of the sides of the same triangle. Here also, I am having the ratio of the sides of the triangle PQR. I need the ratio between ABC and PQR. Okay. So, when I am doing this, I will get AC by PR is equal to BC by QR. So, let us see. AC by PR. So, this side and this side, and I am getting BC by QR. This side and this side. If we are able to prove the similarity between PQ and AB, I can say that the triangles are similar and hence the corresponding angles are equal. Now let us see how we can get the ratio of the third side. Let me see what all data I can gather from the triangles and from sine B is equal to sine Q. I know this particular ratio. So if I can, you know that I cannot say AC is equal to PR because this is just a ratio. So if I am writing this is equal to K, I can say that AC is equal to K into BC and PR is equal to K into QR. Okay, fine. Okay, now let us get to the triangle. Here, this is a 90-degree triangle, which means I can apply the Pythagoras theorem over here. So, the side AB is equal to BC square minus AC square. And the side PQ is equal to QR square minus PR square. Right? AC is equal to K into BC. I am going to substitute AC square as K square into BC square here. So, here I will be getting BC square minus K square BC square, which will give me BC square into 1 minus K square under the root, or this is equal to BC into root of 1 minus K square. Okay. Similarly, I know PR is equal to K into QR. When I am substituting it over here, I will get QR square is equal to QR square minus this, which will give me QR into root of 1 minus K square. Now I am going to take the ratios. So when I am taking the ratios, what will I get? I am going to take the ratio of, let us say, AB divided by PQ. That was the side that we wanted. So AB divided by PQ. Let us see what we are getting. So when I am taking the ratio AB by PQ, it is a ratio of this by the ratio of this. Root of 1 minus K square is a common factor. So I am getting BC by QR. Okay. Now, BC by QR is already equal to AC by PR. All the three sides of two triangles are in ratio. So, I can say that the corresponding angles are equal. Hence, angle B is equal to angle Q. Okay. I hope you have understood it. From sine B is equal to sine Q, I have written the ratio of the sides by taking the definitions. Sine of an angle is opposite side by hypotenuse. Hence, I got this. After getting this, I realized that this is the ratio of the sides of the same triangle. I needed the ratio of the sides of two different triangles because I need to prove similarity. For that, I got PR here and BC over here. I am getting this. I will be using this. I have kept it aside. Then from the same ratio, I wrote it as equal to K so that I get AC in terms of K and BC and PR, sorry, in terms of K and QR. After getting this, I am looking at the triangle. I see I can apply the Pythagoras theorem. I am finding the third side. I am substituting the value of AC in terms of K and BC, and similarly in this triangle also. And when I am finally taking the ratio, I will get this. So I can say that the corresponding angles are equal. Now, one common mistake that I have seen students doing is when they are having sine B is equal to sine Q, they cancel sine and say B is equal to Q. Okay. Why is this wrong? This is wrong because sine is not a variable nor is it a number, it is an operator. It is an operation that we are doing like a multiplication. We are finding the sine of the angle. You cannot cancel sine on both the sides and say that B is equal to Q, though B is actually equal to Q, but that's not the way to do it. Now, if you're asking me for this particular sum, is this the only way to do it? Definitely not. As you move progresses in geometry, you realize that there is a very easy way of doing sine B is equal to sine Q in one step, especially because they are acute angles. That is by taking inverse trigonometric functions, which you will not be learning now. You will be learning about it only in grade 12. So you cannot apply it over here. Now you are learning the basics, and basics are always a little tedious. So this has to be the method you have to approach. This is the raw method that you have to approach by using the ratios, the similarity of the triangles, and the trigonometric ratio. Got it? Okay, so guys, before we move on to more sums regarding the basics of trigonometry, I am hoping that you people have got a very basic idea or at least a basic conceptual clarity about how to approach these sums. We have not moved further in the chapter. We have not moved on to the identities or the values for special angles, but only just the definitions of the trigonometric ratios. I have also told you what are the factors that you need to take care when you are approaching these kind of sums. Now, try to practice as many sums as possible from whichever sources you are getting the sums. I would advise you to go ahead and practice them. Now I keep telling that about all chapters in mathematics, but still trigonometry is a totally new concept for you guys. You have never been introduced to trigonometry before. Exactly one of the reasons why students find it a little tough, because it's a totally different thing compared to the algebra and the constants that you have been used to before. So try to practice as much as possible. So now let us move on to the next sum. In a triangle ABC, right angle at B, tan A is 1 by root 3, and we need to find the value of these two expressions with the information that is given to us. So the first step is always draw a rough diagram. So draw a triangle, mark the 90-degree, mark the relevant angles. So here I have the diagram. It is right angled at B, so this is 90 degrees, so this is B, and this is A, and this is C. Okay, now it is said that tan A is 1 by root 3. Now we know from the definition of tan A is opposite side by adjacent side, which is basically sine A by cos A, actually speaking. Now this is given to be 1 by root 3. So what have I told you? Please do not take the absolute value. So opposite side is not 1 and adjacent side is not root 3. We will be representing opposite side as 1 into k and adjacent side as root 3 into k. So I have my opposite side, which is BC, is equal to 1 into k, and the adjacent side AB is equal to root 3 into k. I know the two sides of a triangle. I can find the third side because it's a right angle triangle by using the Pythagoras theorem, which will give me the value of AC is equal to under the root. What is the value of BC square? K square. What is the value of AB square? 3k square, root 3k the whole square. So I will get 4k square, which will give me 2k. So I am getting the value of AC as 2k. I know the value of AB. I know the value of BC. Now I am at ease to find out the values of sine A, sine C, cos A, cos C, and tan C. So now let us find them one by one and substitute it in this particular expression. I have found out sine A by using opposite side by hypotenuse. Opposite side is BC, hypotenuse is AC. I know the value of both of them. BC is equal to K and AC we found out by using Pythagoras theorem as 2K. I will be getting 1 by 2. Sine C is opposite side to the angle C by hypotenuse, which is AB by AC. I am getting root 3 by 2. Cos A is adjacent side by hypotenuse. For angle A, adjacent side is AB and the hypotenuse is AC. I am getting root 3 by 2 and cos C is 1 by 2. Now tan A is already given to us. Because I did not need to find tan C in this particular expression, I have not found it out. Now let me substitute the values of sine A, cos A and sin C in this expression and find out the value. So what is the value of sine A? Sine A is 1 by 2. What is cos C? 1 by 2 plus what is cos A? Root 3 by 2 and what is sin C? Again root 3 by 2. So what will I get? I will get 1 by 4 plus 3 by 4 which is 1. Okay. Now the next one is cos A cos C. What is cos A into cos C? Root 3 by 2 into 1 by 2. Minus what is sin A into sin C? Root 3 by 2 into 1 by 2. So basically I am multiplying the same and then subtracting in order to give me a 0. Okay. This is very basic and extremely simple. The only thing that you need to remember is that whenever you are getting a ratio like this, you need to understand they are not absolute values and you have to multiply each of the terms by k in order to get the sides. Then the remaining you find out using Pythagoras theorem and then just apply the values as per the definition of the trigonometric ratios. In triangle PQR, right angled at Q, PR plus QR is given to be 25 and PQ is given to be 5. We need to find the value of it to a few trigonometric ratios. Now to find the trigonometric ratios, you need to know the length of the sides. Now what is given to us? It is given to us that PQ is 5 and the sum of these two sides is given to be 25. Now we have to use equations in order to separate the values of the sides and find the values of the individual sides. I have written down the data that is given to us. PQ is equal to 5 and PR plus QR is 25 is given to us. What we know? We know we can apply Pythagoras theorem. So I am applying PR square, which is hypotenuse square, is equal to 5 square plus QR square. I need to find out the values of PR and QR separately. Now, one method of solving this is QR is 25 minus PR. Substitute the value of QR square. Open the bracket, you will get a quadratic equation in PR. Solve for PR. Once you find out the value of PR, you can find out the value of QR also. Now, there is a second method. So, let us do both the methods. So, you guys can select whichever method is more convenient for you. As I have already explained, this is the data that we have in hand. So, from this particular equation, can I write QR is equal to 25 minus PR? Okay. Now, in this particular equation, which is Pythagoras theorem, you have a QR square. Now, I know the value of QR as 25 minus PR means I can write QR square like this. Now, in the Pythagoras theorem, I can apply this. This part, this is QR square. Correct? Now, when I am rearranging, PR square and PR square will get cancelled. Then finally, I will get the value of PR as 13. Once I get the value of PR as 13, I can substitute it over here in order to get the value of QR as a 12 centimeter. Now, individually, we have separated the values of all the three sides of the triangle. That is one method. Now, look at the second method. PR square is 25 plus QR square. We already know about it. When I am taking QR square to this side, it is PR square minus QR square is 25. This is of the form A plus B into A minus B. So, PR plus QR into PR minus QR is 25. PR plus QR we already know the value. What is it equal to? It is equal to 25. So, I will get PR minus QR is 25 by 25 which is equal to 1. I have got two equations. One is PR plus QR and one is PR minus QR. I am adding both the equations. I will get the value of PR as 13. Now I can find the value of QR as 12. This is a very beautiful way of solving those particular equations by using the identity a square minus b square. Now it is left to you. Wherever your logic goes, wherever your thought process flows, you can use the method, but make sure you get the correct answer. So now we have gotten the three sides of the triangle as 12, 13 and 5. Now let us find out the trigonometric ratios. So here you can see that I have written down the values of the three trigonometric ratios which we had to find: sin p, cos p and tan p. Now we have gotten the length of the sides, means it is just direct application of the definition of the ratio. Okay, so I hope you are clear with this kind of sums. So we can move on to the next topic.